Okay, now we have to go into a little bit of mucky muck. We haven't done anything terribly complicated yet, have we? So this is where we kind of get, or yes, we have.
Prepared.
What's that?
So I got prepared.
You got prepared. Okay, so when we actually do regression, if you turn in your book to chapter, I think it's chapter 16. If it's version, do we have version 8? Might be a different chapter, but it's the same information in the chapter.
What's that it looking for?
The regression chapter. It's chapter 16, and version 9 is a chapter.
Is it separate from the correlation?
Yeah, it is. Chapter 16 is a chapter 17, and you guys get an extra chapter in version 8. Way to go! Congratulations. So, the way that you work things with regression, remember we said, what was the purpose of regression? You're trying to predict something. So when we do regression, we try to use one variable to see if we can predict something else. And in this particular situation, we would use BMI to predict what? Snoring. Note, say again? Or sleep apnea. We'll just say snoring in this particular case. So there's a way that this is done. What actually has to be done is SPSS and the other stat programs, they create something called the best fitting line. The best fitting line. And if you turn to, it looks like there's an SAT GPA example. I'm not sure, and I didn't bring both textbooks.
The first page here on 563.
Yeah, there's a little chart that actually has a little scatter plot. Yeah, there it is, with the best fitting line. Can you see how basically what you try to do is draw a line that kind of cuts across all the points? It's called the best fitting line.
Do they sometimes word that line of best fit or something?
Yeah, line of best fit, best fitting line. And what we have here, and what I want to show you, is this information up here actually gives us the equation. I actually even wrote it down here. So you see all this mumbo jumbo here on the screen? Am I recording? I better be. If you look at this, you can see that SPSS came up with what's called the best fitting line. I actually wrote it out here to the best of my ability, but I may need to do a little more writing. You see where I had y hat here? The best fitting line equation, if I make the letter y, just make a little caret on top, that's a hat. Statisticians have nothing to do. So y hat, but it's better than physiological psychology. Was anybody in that class with me teaching the physio? Remember the hippocampus? Somebody looked at it, looked like a seahorse, so they called it a hippocampus. Where do they get this from? Y hat, so the best fitting line equation, y hat equals, and if you look at what I drew out here, do you see where it's got this beta, this b at 6.25? You go 6.25, and then the letter x, and then you have to subtract the constant that's here. You see where it has minus 184.75? What did I convert that to for our equation? Minus 185. So the best fitting line equation, and you can just use this as a formula and the ingredients are there. The best fitting line equation is y hat equals 6.25x minus, we'll just say 185. So how many of you are asking the question of, what the hell is this all about?
Where did you get those numbers from?
Those numbers are basically computed. You'll get a better answer to that in a few minutes.
Okay.
They're actually part of the computation that goes into determining it. The book has all the formulas, but we're going to kind of let that one go. So this is the best fitting line equation. This equation, you could actually draw a line through here based on this equation. So I'm going to take you through a few steps here. And maybe, hopefully, at the end of these couple of steps, you can see what kind of nonsense I'm up to. If you don't, then we'll just try it one more time. So, just give me a little pause here. And let's actually start this situation out. So we have the real data. Do you remember this was back in part 1? Remember we had the BMI 30, the actual snoring episode 10? Do you remember these 5 pairs?
Yes.
So the purpose of regression is to take the BMI and try to predict what? Snoring episodes. So let's try it out. We have an equation there. So you see where it has the X number there? X stands for BMI. So let's actually try one of these values. And if you have a calculator, this will be useful. So what you have to do here first, oh, and I can type it up here. And I did this before class so that I wouldn't be hamstrung. You put the number 30 into that equation. Does anybody have a calculator? Can you put 30 times 6.25 minus 185? So if you put 30 in there, 30 times 6.25 is what, 187.5? And then 187.5 minus 185, the actual predicted number of snoring episodes is 2.5. So when we put a BMI of 30 in, the actual predicted value is 2.5. What was the actual value? It was 10. Do you want that distance to be large or small? You're hoping that's going to be small. So I don't have it up here for you, but if you have the sheet, actually I can do it. What you would do is under the value of 30, just make a little dot for 2.5. A little dot between these two. You want that error to be very, very small. Do I have it right there? Yes, the actual number was 10, but we got 2.5. So your first spot would be right here. So that difference is considered error. Is this working or is this not quite working?
The distance between 2.5 and 10 is the error.
Yes, and so we could actually go to the next column, the distance between those two. What is the amount of error then? You see I've got the column. Oh, you can't see that yet. Why not? What did I not do? Here we go. So I have the column called error. What's the amount of error here? Yep, the amount of error is 7.5. And just for kicks, not that anybody's getting a kick out of this, can you square the error? 56.25. And then we'll go back and get a question. 0.25. Go ahead, Tara.
Why do we square it?
Just because I asked you to.
Okay.
Just for kicks.
It's not like sums of squares or anything like that, is I guess where we were going.
There'll be an endpoint to that, but I can't reveal all my secrets yet. Okay, but the key is to understand that the predicted value said 2.5, the actual was 10, and that's error. You want the distance between the predicted, y hat, and the actual, y value. You want that distance to be small. And you may want to write that down. The distance between y hat, the predicted y, and the actual value to be small. Let's try the next number. Good thing we only have 5, huh? So BMI was 32. If you put that in your calculator, 32 times what? 6.25 minus 185. What is the predicted number of snoring episodes? 15. Good news or bad news? That's great news because the predicted value is actually, it's the same value as what we got. So if you're making your little scatter, you're making your best fitting line, I had the one at 2.5 down here. then the next one is right on the mark. How much error is associated with this one? 0. And of course, 0 squared is the Billy Preston song. Nothing from nothing leaves nothing. Does anybody know the next line? What is it? If you're going to be with me. Exactly. It was from the 70s. Billy Preston was, in fact, the fifth Beatle. He died recently, though.
Really?
He was playing on the rooftop. It's true. As academicians, I try to learn as many useless facts that might be amusing to people as I can get, because God knows there's nothing interesting about any of this. Okay. Now back to our story. 35. If you put in the number 35 times 6.25 minus 185, I believe the predicted number of snoring episodes would be about 33.75. So how much error, what was the actual value supposed to be? 25. So now, if you look at my sheet here, do you see where it's 25 here? Now you kind of have to be a bit above that. So how much error for that one? Say again?
8.7.
Exactly, 8.75. And if you square 8.75, you get 76.5. We'll just do a round. Okay, let's take the next one. 38. If you put the value of 38 in there, you might get 52.5. You might not. Are we using smartphones here or still calculators? Does my smartphone actually do this? Jesus Christ, this thing is smarter than I am. I should tell you, my daughter did something amusing over the weekend because she knows how to do these things better. She said, "Oh, Dad, I can put all these songs from the 70s and 80s on iTunes." And so she took it and she did it, and she was like, "Oh no, I've converted your iPhone into my iPhone." It's kind of a bummer. So we had to go to Verizon and like, well, we have to get everything off of your iPhone. So, that was an experiment that didn't work out so well. But I've only had this for a couple of weeks, so God knows I don't know what's going on. So anyway, back to our story. 52.5, did you guys get that? Stalling for time here. And how about for the error amount? What was the predicted value?
46.5.
So it was 40, so now we're at 12.5 squared. 156.25. I'll just do about one. Yeah, we can do the 25 there. And one more. Thankfully, only 5. When it's a value of 40, what was the predicted value? 65. The amount of error is then 15, and 15 squared is 225. So the reason I go through this is to illustrate the point that if you make the best fitting line, if you draw them up, and God knows I'm a terrible artist, but you can create a best fitting line, a good best fitting line, there should be little distance between what? What you
Predicted and
what actually happened, because in the future you might use it for a study. So that's what we want. A good best fitting line does a good job of having a small difference between what is predicted and what is actually found. And so in this case, the question is, well, how do we know if this is good or not good? But this is the way it's actually set up. So now we're going to go to how we actually get the answers that we want. And I think we may go to the next part of the tape. You're through the hard stuff here. We're